Welcome back. If you are seeing our videos and you are finding them helpful and interesting, please give a like and you can subscribe. That will encourage us and we feel that okay, somebody is making use of the material we are preparing here. So you have done integer addition or any program for that matter. At any point of time, you want to see what is the value in a particular variable storage, or you want to see where it is in a register. And unlike in COBOL kind of a places, you have very easy command say display and you give the variable name, the value will be shown. Unfortunately, in assembler, it is not that easy. So one of the ways of achieving it is a macro called snap. Basically takes a snap of the storage registers and save area at a particular point of time. Let us say you take L R1 num1 and you done say some multiplication of it and you want to put the result into say result 1. So you want to see what is there in the result 1 and maybe you also want to see what is there in the register 1. So to get those values we use snap command. How we do it, how do we define those variables, what is that we need to add in the data definition area dissect, and what we should put in the program is something I will show you. One thing is there, this macro may not be available everywhere, but most of the time it is available. And also you need to practice with this. If you say you've done some command and you just put the snap and you ensure that where that particular file is defined in the storage area, the similarly its corresponding value is there in the GCL. In the next 2-3 slides I will show that. Best is take this piece of code, put it in your program wherever it is appropriate, and then you will be able to see the register values, save area values, and the values that are stored in the data storage section. Let's move on. So let us look at this. This is the snap macro that is available in the assembler. First, what we are doing is we are opening the snap DCB file and we are closing it. In between, we have the snap where DCB equal to snap DCB. That is the file name we are giving. We are defining that file and also its corresponding value should be there in the JCL as well. You can call it whatever you want. I'm just calling it a snap DCB. It doesn't have to be snap DCB. It could be something say my debug one, something like that. Whatever you want to put, you can put it. But what it is fundamentally telling is put in this particular file, and this file we are defining in the JCL as snap DCB something dot whatever it is, or most of the times it just goes into the sysdump. So snap DCB is the name of the file. You can give ID equal to 1, 2, 3, 4 like that, just to identify if you have multiple places you are taking the dump and putting it. You can call it different values. This has to be only numeric, it can't be anything else. You can pass it as a parameter, but mostly it is a numeric. Storage equal to message comma workend. So we will define in our data section. I will show you in the next slide. Any two variables. The first one is the starting point of the storage which you want to show, and last one generally we say star. I will show you. So this is the starting point of the variables which you want to display, and this is the last one. So whatever is there in between, it will show. P data equal to regs registers. SA is the save area. So if you don't want to see all the registers, you can comment this, just comment this entire thing. You don't want to see what is in the save area also, you can comment. Typically what most of the time we will do is that, let us say you have loaded num1 into R1 and then you have done some multiplication and you stored back a value called num2 or result or whatever it is. That result is what you define in your data section, and you say result comma say workend. So whatever is there between these two variables in the data section, it will show the entire thing. If you put a p data equal to regs sa, if you put this, it will also show the data of the registers and it will also show the storage area. Very important, this open and close. Again, there are some issues. Sometimes some installations allow these brackets, sometimes it doesn't allow. So you have done an instruction here and immediately you want to see the value, you can do this. This is not so straightforward. Once you start putting it in the program, I'm sure 3, 4, 5 times it will abort unless you get it right. But follow this syntax. In the data storage section, define the file and you open it, you put it this way and you close it. Now let us see what is there in our data section. So what we are doing here in the working storage, first we are defining the save areas DS18F. We have seen it in the previous class, why we are calling the save area and what values are getting stored when a program is getting called, or it is going back, returning back to the original program. These three fields I want to show, it could be anything: message, counter, amount. Let us say I want to know that I want to see always values of some registers: register 4, register 5, register 6. You just say reg 4, reg 5, reg 6, and you populate those values. It is nothing but a storage area. Anything can be here. And here what I have done, I have initialized it CL30. This is my initial message. Counter I have done it as F1 and amount as a F2500. And the last one in this will be work and equal to star. That means basically it will should show a star. So what is happening? This I am repeating this snap demo command one more time. DCP snap DCP. Remember we have defined it already in the working storage section as a file. Then storage equal to message to workend. That means whatever in between this 4, it is going to show that. Their names could be anything, right? It could be message or it could be something else, and the number of fields could be 10, number of fields could be 2, but last one will be star, so that the program knows that it is ending. And as I said, pre-data, if you want to see all the registers, all the save area, you can do it. Otherwise you can just comment this. That's why we have put this X here, and you can remove this X and you put a star here and close snap DCP. Then you can go back and see the values. Again, when the snap DCP comes, mostly it comes in the, this is something very useful when you are doing something like a packet decimal and all that. But when you are doing a characters, this is my initial message, right? You are not going to see this. You are going to see whatever the hexa equivalent of T, what is hexa equivalent of H, like that. You are not going to see this is my initial message. If you want to still convert them, then maybe you have to expand this a little bit about more on this macro and make them using a edit command and make them look a readable format. But you understand this much. You snap DCB we have declared, put it in the working storage. This is then we are using this in our program, and this values we are defining in the working storage. From message to workend it will show. Okay, let's move on. Though this is a very small module, very useful module. If you have already run a program, if you already created a assembler program, it could be as simple as L R1 num1, something like that. Look into it, practice it, put the snap command there, create a file, define the variables, and put the snap macro and see what is there in R1, or in a variable say num1 what is there. You can also use this p data. If you want to just to put regs, all the registers data will be shown. If you don't put regs and if you put save only, it will show you what is in the save area. If you want to see everything, you see everything. Try this. This is going to be very useful when it comes to debugging. Okay, thank you.